Hi, welcome back. Let's review what we learned yesterday. Aerodynamics is how easily something moves through the air. Gravity is the opposite of lift. This is the force that pulls us toward Earth. Gravity keeps us on the ground. Lift is created by the difference in pressure above and below the wing of our airplane. Lower pressure above the wing and higher pressure below the wing is what causes it to lift. There are 4 forces of motion: lift, drag, thrust, and gravity. Today, we're going to discuss another force of motion, drag. And again, your essential question is, what are the 4 forces of motion? Define each force. Drag is the amount of resistance something has when moving. To make this a little easier to remember, I want you to think of drag as something that slows you down. So if I am running across this living room and I put a big weight around me and the weight's dragging on the ground, it's giving me a resistance, right? It's going to slow me down. So that's drag. So think of it that way. Think back to your hand moving through the air. In which position was there more drag? There was more resistance when our palm was facing sideways and our thumb was on top, right? This is because our hand had to push through more air, creating resistance or drag. We're going to add the term to the chart that I showed you guys yesterday, and I'm just going to show you the one in my notes to make it a little easier. Drag is the air that's pushing against the airplane, slowing it down. So it's the air going this way. Okay? So what does that mean for our paper airplanes? When an airplane flies through the air, it runs into air molecules that causes it to slow down, which is kind of what we felt when we were moving our hand. Remember, energy cannot be created or destroyed. We learned this in the last chapter. Energy must go somewhere. And in the case of drag, the energy of the paper airplane is transferred into the air that is in its path, slowing it down. To get your paper airplane to fly as far as possible, you need to have as little drag as possible. Do you think an airplane's wing shape would affect the amount of drag or resistance? Yeah. So when you are building your paper airplane, the shape that you give your wing is going to affect the drag or how far it flies. So I want you to play around with different shapes. I'll give you an example. I built a paper airplane, and this is really the only way I know how to do them. But if you are allowed, ask mom and dad first. But if you are allowed to get online and look up different paper airplane shapes, I bet you can find a shape that would fly further than mine. Because do you think my wings of my airplane, or how about this gap that's in here? Do you think that's going to create drag? Or how about how big my airplane is? Does it need to be this big? Does it need to be a full sheet of paper? These are things to think about when you're making your paper airplane. Another thing to think about is the weight. This is computer paper that I had printed one of your charts on, and it's going to be a lot heavier than tissue paper or a paper towel, but it's not going to be as heavy as, say, cardboard or construction paper. How is that going to affect? Remember, our weight is gravity. So we've got lift and gravity and drag. Put all those together and start thinking about your paper airplane. So for today's homework, I want you to find a sheet of paper at home. It can be any kind of paper that you find: tissue paper, wrapping paper, construction paper, computer paper, a napkin, a paper towel, whatever you want to use. Practice folding your paper into different shapes to see what shapes create the least amount of drag. And again, think about that wing shape. And then there are a few questions on Unified Classroom I want you to answer. You're going to tell me what drag is, and you're going to tell me how it affected your paper airplane. Okay? Have fun. I will talk to you guys tomorrow. Bye.